All right, so guys, we have our projectile motion test review tomorrow. So what two things are required for a vector quantity? Do you know? Not sure. Does anyone know? Sick. That's why we're going here. Yeah. Yeah. Okay. So vector represented by an arrow. Okay. Magnitude and okay. Get out. Goodbye. Stop. No. Yes. Okay. Sheesh. So yes, vector direction. All right. It is a quantity that requires both magnitude and direction. So when we for example, draw in Vx because it's in the x direction, okay, we're showing it in this direction, all right? The arrow is going to represent the speed or velocity, okay, and it's moving in this direction. And then as it's moving through the air, what acts on the object, guys? Right? In the y direction, what starts moving the object? What pulls the object to the ground? If there was no blank, this ball would just keep moving straight at the same speed. What causes it to fall? Gravity. So every second later, now gravity starts to add some speed to it, moving downward. But this Vx stays the same. So every second it's going to move the same distance to the right. All right, your Vx will be the same, but every second it's falling, the vertical velocity, the y velocity in the y direction is going to start increasing. Does anyone have Mr. Mo? Yesterday they had to do an assignment. I don't know if you guys had any of your friends doing it, where they had to walk around to different rooms and stuff and find parabolas. So guess what? A projectile has the path that is shaped like a. That is correct. Parabola. All right. If it's launched horizontally, it's a half parabola, but parabola nonetheless. During the path of a projectile, when is the height the highest? So, yeah, at the top. That's when the height is the highest. Makes sense. Okay. Okay, sweet. We'll continue, and we'll kind of touch back on this in a second. Now, the instant a ball is thrown horizontally with a large force, and an identical ball is dropped from the same height, which one hits the ground first? All right, so yeah. So if I just do this real quick. So we've looked at this before, guys. We have used this before, so we're just going to take a quick peek at this again.
Is there a pass for the bathroom?
There is a small orange pass over there should be. All right, so guys, we're going to take any angle out of there because we are not shooting anything off at any upward, downward angle. All of our problems are horizontal. So number 4 asks, the instant a ball is thrown horizontally with a large force, an identical one is dropped from the same height. Which one hits the ground first? Now, if you put this at 0, it actually doesn't go anywhere. So where's the little start button? Oh, here. Ready? So this is almost straight down. Well, how much time? 3.91. Okay, now remember that time. What is it? 3.91. Now, if I launch this sucker at a much faster angle, or much faster speed, I apologize. See how much farther it goes out? But how much time did it take? The same. So the x component of this motion is not affected by the y, or the y is not affected by the x. So the answer to this one then would be same time. In the absence of air resistance, which angle will the ball go the farthest? At what angle does this thing go the furthest? 45. Very good. All right, it's equal parts of x and y. So if this is your 90 degrees, 0 degrees, 45 is like the sweet spot. It's going to give it the farthest possible range. Okay, you're 45 degrees. Now, this is going to answer one of the questions in the next piece. But if I had said I launched something at 70 degrees, and it lands there, what angle can I launch this at where it will go the same distance? Does anyone remember that? Very good. It would be 20. Why? Because any two angles that add up to 90 degrees will have the same, all right, delta x. They will go the same distance. So here's a question. If I launch something at 30 degrees, what other angle could I launch it at so that we have the same delta x? 60. What about 40 degrees? 50. All right, so you guys got that. Excellent. What part of the path does the object have the minimum speed? Okay, at the top. Why? Because Vy will equal 0. Vertical velocity, all right, is 0. All right, a projectile launched horizontally hits the ground in 0.75 seconds. If it had been launched at a much higher speed in the same direction and from the same height, would it have hit the ground in less than 0.75, exactly 0.75, or more than 0.75? Correct. Yep. So that's the same thing, guys, again in the simulation. All right, we just launched this thing at 57 meters per second, and it was in the air for this long. If I now change the speed to something very slow, in the air for the same amount of time. Okay, a projectile is fired horizontally with no air resistance. Is the horizontal velocity constant or changing? All right, Vx is constant. All right, so we're assuming no air resistance. So if I were to take a look at this pen, okay, and if I imagine pushing it, all right, through the air, if there is no air resistance, as soon as it leaves my fingertips, as soon as this thing leaves my fingertip, right? If I go to throw it, as soon as it leaves my fingertip, I no longer have a driving force behind it to cause it to accelerate. So it's going to move at whatever velocity we gave it. And if there's no air resistance going in this direction or upward, nothing's going to slow it down in the x direction. So that is why it remains constant. And so what we just want to add to that is because there are no forces in the x direction. Oh yeah, piranha. Don't you tell me to stop. Do what I want. All right, so ball is thrown upward at the top of its path. What is the acceleration in the y direction? All right. Well, here I'm going to draw this. Yep. So at the top of its path, Vy, vertical speed, is equal to 0. But what about the acceleration? The acceleration in the y direction is equal to gravity. All right. What value do we use for gravity? Negative 10 meters per second squared. But what is the true number? 9.8. Good. All right, we just use the 10 because sometimes it makes our calculations and everything come out nice and neat. So, oh snap, we basically just answered this one. All right, so at the top of the path, the acceleration in the y direction, negative 10. At the top of its path, its instantaneous speed, all right, if it's just thrown straight upward, then it's 0. Okay, now this one. So we're going to have so at 0 seconds, let's say we have a vertical velocity of 30 meters per second. The next second up, because they want to know how is the Vy changing. So guys, what is gravity again? Negative 10, right? So if you just toss your pencil up straight up right now, does it speed up on the way up? No, it slows down. How much does it slow down by every second that it's in air? By 10. So if it was in the air for 1 second, that 30 is now going to become 20. In the air for 2 seconds, it becomes 10. At 3 seconds, it's 0. Now at 4 seconds, it's going to speed up by 10 on the way back down. So it slows down by 10 on the way up and is going to speed up by 10 on the way down. That would be 5 seconds, and this last one of 6 seconds. Oh, no, I should have probably made this a little bit higher, whatever. All right, so it slows down by 10 meters per second every second. on the way up until it runs out of speed in the y direction, and then changes direction and speeds up by 10 meters per second on the way down. And that's why we have negatives there, because the negatives for velocity are indicating our direction. These little arrows are representing that vector. Okay. So now, when you launch an object at an angle, how does the time for the projectile to reach the peak compare for it to fall back down? So assuming we're on a flat surface, not from a cliff, we launch it at whatever time. Let's say it takes 1, 2, 3 seconds to reach the top, and then 4, 5, 6 to hit the ground. So 0 seconds, 3 seconds, 6 seconds. That means time up will equal time down. Oh snap, we already answered this one kind of on the beginning. All right, on the front side. If I launch a projectile at 30 meters per second at an angle of 20 degrees, it will have a horizontal displacement of 59.04 meters. At what other angle could I launch this and it would have the same horizontal displacement? 70, right? Because any two angles that add up to 90, all right, will have the same horizontal displacement. So the answer would be 70 degrees, 90 minus 20. Any two angles that add up to 90 degrees. Okay, and then just give one other example. Trent, give me two numbers to add up to 90. Correct. What? 89.1. Yeah, that would technically work. Okay, so if I launch something at 89 degrees, which is almost like straight up, and then 1 degrees, they're going to have the same horizontal displacement. But how does the time of flight get affected by that? Which one do you think is going to spend more time in the air? If I launch it at 89 degrees or at 1 degrees? If this is 90 and this is 0. Which one do you think is going to be in the air longer?
89.
Yeah. Okay, which one do you think is going to be in the air longer, 50 or 40?
50.
Correct. What about 70? 70 or 20?
70.
So, the closer it is to 90 degrees, the more time it will be in air.
What's the number after 70? Like it says equals 70 meters.
I just did 90 minus 20. All right. So I am going to have you guys do some of these on your own because I want you to get this full practice in. I want you guys to work out any of the last little bit of kinks. All right, some of these are very, very similar to the homework that we had just gone over. All right. Plus, I also had already made a video for those. So 15 and 16, all right, we've basically already done. So I want to go over 17, and I want to list and label exactly how I would score this. All right? So please make sure that you are doing this as we're doing this right now. Okay. So, guys, what was one of the things I said to you 10 minutes ago? Any speed you're given in a problem, what is it? Is it going to be? It's going to be Vx. So Vx, 32 meters per second. So you guys still want to have this guy out, all right? Your equation sheets. Okay, what else did they give us? They said, okay, we're launching something horizontally from the top of a So we got Vx is 32, and this thing is how high? 1,050 meters. They want to know delta x. All right. So we have Vx is 32. The height of this thing, which is 1,050 meters. And then how far from the base of the tower does the projectile hit the ground? All right. Well, that means we want delta x. Okay, so all of that, 1 point. All right, so you don't have to do the drawing, but listing your given information. So I just gave you the drawing so you could see it a little more visually. All right, the next step that you guys should do is to do what? Write the equation for your question mark. So I don't remember that off the top of my head, so I go to my equation sheet. Delta x is Vx times time. Cool. All right. Guys, let me know. Do we have Vx?
Yeah.
We do. What is it? All right, 32. So I'm going to put 32 directly underneath Vx. Snap. What do I not have?
Time.
I don't have time.
So you gotta do that order.
So usually in these problems, right, you'll need to find time first. So if you have both Vx and dx, you use this, but we don't because we're looking for delta x.
You gotta do 2.
So we got to use this equation for time, 2 dy over 10. So we're going to do a little side quest here for t. T is equal to 2 dy over 10 square root. Okay, that would be writing this equation out is your second point. This one would be your third point. Writing the math for this, right, showing your work, that is your fourth point. Getting this answer, rounding it to 2 decimals. So 2 times this divided by 10, and then to square root this. So if you guys don't know how to use the square root, well, there's another little simple thing you can do. I don't know if I should show you it because I don't want you guys getting confused, but I'm going to show it anyway. Does anyone know another way to square root on this calculator? Ready for this? You see like the raised to button? If you just take this and raise the answer to 0.5, it gives you this. It's the same thing as square root. Don't know why, it just does. So again, if I went square root of 210, I get my 14.49. And if I did 210 raised to the 0.5, it's the same answer. So round this to 2 decimals. So this is 14.49 seconds. That's my 5th point. The 6th point, all right, now what do I need to do is I need to take this time and plop it in here for t. $14.49, bam. And now that would be my 6th point, all right, because I showed my work for it. And now that gives me an answer here of, when I type it into my calculator, 463.68 meters. This would be your 7th, getting the right number, and 8th, the right unit. So 8-point problem right here. And guys, again, it may seem tedious, but there's a method to it because it provides you a structure to follow. Okay, writing out your given informations and what we're looking for. That should always be your first step. Write the equation for what you're looking for, because that tells you, do I have all my information that I need? If I do, awesome, just solve it, go for it. If not, like we didn't have t, so that means, okay, we had to look at our equation sheet and figure out what to do, right? Which was basically listed right here for us. So we couldn't use this one, so we had to use this. We plugged it in, got our answer, and boom, shakalaka, we did it. So I do want to show, we can do either 18 or 19. Which one would you guys rather do? Yep. They're pretty much the exact same.
Do 18.
We'll do 18. Okay. All right. So I'm gonna wind up posting the video that we're just making right now for this. All right.
I have to finish it.
I would just do your best. If you don't,
Is it homework?
if you're comfortable with it, like if you know what you're good, we're good. All right. So let's take a look. We said 18. Okay. So we got a person standing on a cliff. All right, and they throw a stone with a horizontal speed. So we got a rock is getting tossed with a Vx horizontal speed of 22 meters per second. And then it says it lands 53 meters away from the base. So if it's away from the base, that's your delta x. So that is your 53 meters. They want to know how high up is the cliff. All right, so let's write. Again, I'm just doing the drawing. You guys are not going to be required to do the drawing, but what you will be doing is writing out your variables. So Vx, delta x, and your question mark. What should be my next step? equation. So looking at my equation sheet, Chris, what is going to be the equation for dy? Just look up here.
The first one. No.
Dy. 1/2 gt squared. So we're going to write that. Cool. All right. So Lewis, can you do me a favor? Do you know what value we use for g?
Don't remember.
Anybody?
What, G?
Yep.
Negative 10.
-10.
Yeah.
All right, that's gravity. So guys, real quick, what's 1/2 of -10?
-5.
So -5. And awesome, but wait a minute. Do we have t?
No.
No. So we got to find t. Okay. Now this says if you have Vx and delta x, use this equation. Do we have both Vx and delta x?
Yeah.
Yeah. So we're going to do this equation for t. All right. Delta x over Vx. So this will be your third point. This will be your third point. Substitute your numbers in, and that would be 53 for delta x and 22 for Vx. And it's going to kick out a number with a decimal. We're going to round it to 2 decimals. We're going to call it 2.41 seconds. So this equation, third point, the work for it, fourth, the answer to that, fifth. And now we got to take this guy and we're going to plug this in for t. Now remember that t is squared, only t. So you're going to do 2.41 squared. So we throw that into the calculator. 2.41 squared times by -5. And this gives us a vertical displacement of -29.04 meters. So guys, what this -29.4 meters is saying is that once the ball lands here, it is 29.4 meters below where it started. But the question asks, how high is the cliff? Can you have a negative height? No, so what do you got to do? Just drop it. So 29.04 meters. Okay, so I want you guys working on, all right, the remaining problems. All right. This is, guys, where you want to work out the last little bit of your kinks, questions that you're not sure on, okay? This would be the time. Yes, sir.